In today's video, we're going to be talking about trusses. Okay, now we have a diagram on the board that gives an example on trusses. But first of all, what is a truss? A truss is a triangular member used for supporting load. Now, a very good example of a truss is in a roof. Okay, now in a roof, we can find different structural members, of which trusses are the most common there. Okay, they can either be made from wood or any metal. Okay, now they're used in construction of roofs. Now I have a diagram here for truss, and it's triangular, like I said, and having different forces. Now in trusses, we do have what we call compression and tension as well. Okay, and in most cases you'll be asked to check if the force acting on the member is tension or compression, tension or compression, tension or compression, of which you'll be able to identify by determining the direction of forces, and there are rules to this as well. Okay, and also you'll be asked to find the compressive or the tensile force acting on that particular member. Now there are rules to doing this, and I'm going to start with an easy example like this. Okay, I'm going to sketch through it and see how easy it is to find the tension, okay, or compression in these members, or even identify if there is a tension or a compression in these members. Now basically there are two methods for doing this. We have the method of section and we have the method of joints. Now the method of joints is quite easy, okay, or easier than the method of section, but some examinations will require you to make use of any of the methods. They might specify either to use the method of joints or the method of section. Now it really doesn't matter. We're going to start with the method of joints, which is easier than the method of section, and we're going to apply it to this question on the board and see how it is being done. Okay, now to do this, we're going to analyze each of the joints. Now having three joints here, okay, or having a joint here, a joint here, as well as a joint on this side. Okay, now that's what you notice. There are three joints here. What we must first do is we analyze each of these joints. Now these joints A, joint B, and joint C. Now I'm going to pick one joint to start with first. But how do we know the joint to pick? Now we cannot just pick any joint at all. Okay, now here is the rule to pick, selecting the first joint. To do that, we must select a joint that is having at least at most 3 members. Okay, now if you come to this joint, you are just seeing a member here and a member here. Okay, when we come to this joint, you are just seeing a member here and a member here as well. Now when we look at this, we also have 2 members, but we notice that this particular joint here has a force which is 500 Newton. So to analyze the particular joint, we must choose a joint first in such a way that we'll be having 3 values. Okay, now here we're going to have member BA, member BC, and then we're having a 500 Newton. That's what we're going to have. Okay, now first of all, let's check to see if the force on this member BC is either compression or tension. That's what we're going to do first, and we're going to find the compressive or the tensile force. Okay, now to do that, we're going to draw this joint. So I'm going to call here joint B. Okay, and there's a force of 500 Newton acting towards the positive x-axis or towards the right. Okay, now we're having a member BA, which I'm going to draw as well. Okay, and first of all, we're going to draw a line without indicating the arrow. Okay, and I'm going to call it force member BA, and for this guy BC, I will as well draw a force, okay, without indicating the direction yet, FBC. Okay, now what's our next step? The next step, we're going to assume either of these ones to be tension or compression. I can choose not to be tension, choose not to be compression. Now if I choose this to be compression and I solve for the value, if I get a negative value, it means it is actually a tensile force that is acting on it. But if I assume it to be tension and I get a negative value, it means it is actually a compressive force that is supposed to act on it, not a tensile force like I assume. But if I choose a tensile force and I get positive, it means it's actually what now? A tensile force. If I choose a tensile force and I get negative, it means it is not. Okay, so whichever force I choose, if it is positive, it means you are correct. If it is negative, it means you should choose the reverse one. Same thing applies for any member you pick at all. Okay, so then we're having member FB. Okay, Now, here is a pin. Here is a pin. Any force that is pulling on pin B, that is, if the force is dragging pin B that is pulling it in this direction, it means there is tension on pin B. Okay, so I'm going to write for a pull on any pin, there is a tension acting on it, or a tensile force. That's what it means. Of which the opposite is true. If there is a push, okay, on the pin, it means it is compressive. Okay, now we're going to work with this one, the pull on the pin. Okay, so since we are dealing with joint B, which is a pin here, if I should draw an arrow here, okay, this arrow is pulling joint B. Okay, it's pulling away from joint B. So I'm going to assume that the force here is what? Is compression, because I just said a pull is tension rather. Okay, a pull is tension. So I'm going to say assume that it is tension. We don't know if it's actually tension or compression yet, we're just assuming. Okay, now for this, if I should, let's say, draw it in this direction, okay, if I should draw it in this direction, I can pick any direction. If I should draw it in this direction, it is going towards B. Okay, that is a push. It's going towards B. That is a push. It means it is compression. Okay, it means the force BC is what now? Compression. So I'm going to assume that it is what now? Compression right here. Now the next thing, I'm going to create my equilibrium equation, of which I assume you guys not to create before now. Okay, but if not, there will be other videos created for that, for you to understand the equilibrium of forces as well. Okay, now let's first of all solve for force FBC, because of which, if we decide to try FBA first, we won't be able to solve it because there's no force acting vertically apart from FBC, FBA. Okay, or we could as well resolve this one, and we don't know FBC, so we can find it by resolving to the horizontal using this 500 and obtain FBC. Okay, now let's do that. So I'm going to write summation on the x-axis, okay, for the forces on the x-axis, okay, creating the equilibrium equation. I will need to know the angle here at first. Okay, now what's the angle there? Let's come to the diagram. We are given an angle of 45 degrees here. Okay, here is 2, here is 2, so we know here is perpendicular. That creates an isosceles triangle, right? Here is 2, here is 2. Here is obviously 90 because of the 2 here and the 45. Okay, and then the angle here has to be what now? 45 degrees. Now why is it 45 degrees? From geometry, we do know that if we have two sides of an isosceles triangle which are equal, it means the base angle will be equal as well. So if here is theta, here is theta, and the apex angle, the other angle is usually 90. Okay, it is usually 90, or even if it is not 90, to get that angle is simply 180 minus 2 theta. Okay, so if it is 90, it is perpendicular, but if it is not 90, you could as well find it. So assuming here is 30, 30, we get 60, 180 minus 60, that's 120. It means the angle is what now? 120. So it's not always 90. Okay, but in most cases, just like the truss, it is 90. Okay, now sigma x is equal to 0, or we could say summation of the forces on the left hand side equals summation of the forces on the right hand side. So I'm going to assume that sigma x is equal to 0 in this case. Okay, sigma x is equal to 0. Now let's solve for that. Here is 45 degrees. Now we're resolving this towards this horizontal axis, and the direction will be in the negative x direction. So that should be minus. So have minus FBC. Okay, opening the angle, we have sine of 45 degrees. Okay, now this one is going towards the positive x axis. To have plus 500 newtons equals what? 0. Now how do we solve for this? We could as well make FBC solid formula, of which FBC taken to the other side becomes 500 over sine 45 degrees. Remember, we're assuming FBC in this case to be compressive. That's why there's a C here. We don't know if it's actually compressive, but just assuming. Okay, so having FBC equals 500 divided by sine 45 degrees. So we'll do that. 500 divided by sine of 45 degrees. What we're going to obtain is 707.1 newtons. Okay, that's what we're going to get first. 707.1 newtons. Okay, now we can as well find FBA since we already know the value of FBC. Okay, to do that, we take the summation. Okay, we can take the summation of the forces on the y-axis and equate it to 0, creating the vertical equilibrium equation. Okay, now by doing that, all the forces on the vertical axis should equal 0, of which this one is going towards the negative y-axis, so you get minus FBA. Okay, minus FBA, and then resolving this one to this component, it becomes vertical, and it will be facing one direction, the upward direction. So we should be having a positive FBC cosine of 45 degrees. You should know why it's cosine, because in this case we are closing the angle. Okay, and that should equal 0 as well. So to solve for FBA, when you take it to the other side, it becomes equal to FBC, of which FBC is 707. Okay, you get 707.1 cosine of 45 degrees. And what are we going to obtain at the end? Okay, 707 cosine of 45 degrees, so we'll multiply our answer by cosine 45 degrees. We're going to get 500 newtons. Okay, there's no approximation in this case, so we're getting exactly 500 newtons. That's what we're obtaining. Now, how do we identify if the forces are tensile or compressive, like we said? Now I said, if we assume here to be compressive, okay, or if we assume here to be compressive and we solve, if we get a positive answer, it means it's compressive. If we get a negative answer, it means it is the reverse, which is tension. Okay, that's a tensile force. But if we assume it to be tension, if we solve and we get a positive answer, it is tension. If we solve and we get a negative answer, it is what now? Compression. Now we assume this guy to be compression. Okay, we assume it to be compression. And then we solve for FBC and we obtain a positive answer. It means we are correct to say that the force acting on this bar, okay, BC, is actually a compressive force. So I'll just come here and I'll say compression. Okay, that's what I'm going to do. Now, how about this one? We are assuming it to be a tensile force. Okay, so we solved and we obtained 500 newtons. It means and our answer is positive. It means that this is actually a tensile force. So I'm going to come here and I'll write tension. Okay, it means there is tension acting on it, which means there is a pull in this direction, stretching it. Okay, and for this one, there is a push in both directions, telling us that it's what now? It is a compressive force. Now, to get these other ones, we might also want to analyze the joints. Okay, now before now, you should know about what we call a fixed joint and a movable joint. Now for this one, we notice that the joint is able to move towards the left and right because there are no two supports here. There's no rigid supports. Okay, now this joint is free to move towards the left or right, but it is not free to move vertically upward. So there's a restriction. Okay, vertically upward. So since there's a restriction vertically upward, I can say there is a force that will act on it, FC. Okay, now this one is not free to move towards the left or right, neither is it free to move upward. So I'm going to write this as FCY to say that it's vertical. I'm going to come here and I'll write F is joint A, FAX. Okay, so there is a restriction towards the left or right. That's why there is a force here. And then I'm going to come here and I'll write FAY. Okay, that's what I'm going to do. Now the next thing I want to do is analyze joint C. Let's analyze joint C and see what we're going to get. Now for joint C, there is a vertical force FYC. There's a vertical force FYC which is unknown. Okay, now we just found out that there is a force, there's a compressive force in this direction. There's a compressive force of which is having a value FBC, which is equal to 707.1 newtons. So I'm going to draw another force like this, okay, in this direction, and it's going to have a value of 707.1 newtons. Okay, and then there is a force here which is unknown as well, and that force we are going to call FCA. Okay, I'm going to call that force FCA. Now what do you notice in this case? Since the force, the arrow, is pulling out from the point C, which is the joint, you notice that the arrow is coming out of point C. According to what I will say, if there is a pull, it means we are going to assume that there is tension. Okay, so any value we solve for FCA, it simply means that if the value is positive, it is actually tension due to our direction. If it is negative, it means it has to be what now? Compression. Okay, so now let's solve and see what we're going to get. Okay, what are we going to get? Now in this case, there is an angle there, 45 degrees. An angle of 45 degrees. Now let's solve for FCA and FCY and see what we're going to get. Okay, now this one is going in the positive direction of y, so we're going to take summation of the forces along the y-axis, okay, should equal 0 for equilibrium to occur. Okay, so when I add all the forces going towards the y-axis, I should get 0. Okay, this one is going towards the positive y-axis, so I'll have FCY. Okay, that's what I'm going to get. Now this one is going in this direction. When I resolve it, bringing it to this direction, okay, facing the positive y-axis, I'm going to get plus 707.1, okay, sine of 45 degrees equals 0. That's what I'm going to get. FCY plus 707.1 sine of 45 degrees equals 0. So I'm going to say from here, FCY, okay, FCY is equal to minus 707.1 sine 45 degrees. Okay, I think that should give you negative 500. So I have 707.1 sine of 45 degrees. That should give you 499.995. That's approximately 500. So I could say this is 500 newtons. This is negative 500 newtons. Now this time around, this is a reaction. Okay, now reaction can neither be compressive nor a tensile force. It is neither compressive nor tensile. Okay, so we don't need to identify if it is compression or tension. The only thing that the negative sign is going to tell us is the direction of the reaction. Now I assume the reaction to be going upward. It could be going downward. It doesn't really matter. Of which in this case I assume it to be going upward. So I obtain a negative answer. It means there is a reaction of 500 newtons that is going downward in this point C. So there is a reaction. I could say that FYC is equal to 500 newtons in this direction. Okay, in this direction. Now how do we find FCA, which is the main focus, to tell if this is compressive or if it is tension? Okay, now to do that, we are going to take the summation about the x-axis and equate it to 0. Okay, for this case we are going to have FCA. Now this is moving in this direction, so that should be negative, right? So we have negative FCA, which is the negative x-axis. Now how about this? When we resolve this, you should also get negative sign, right? So you should get minus 707.1, okay, plotting the angle cosine of 45 degrees, and that is equal to 0. Now when I do this math again, I should get 500. So I'll have minus FCA minus 500 equals 0. Okay, collecting like them to obtain FCA to equal, that should also give us minus 500 newtons. Now this is not a reaction, so I'm not going to say the 500 simply means it is the opposite direction that we picked. Okay, but in terms of the force acting on this bar FC, we assume the force to be tension because it is pulling out of point C. We assume it to be tension, right? Now since we assume it to be tension and we obtain a negative answer out of this case, it means this force here has to be what now? Compression. So I'm going to come here, okay, and I'll say the force here is actually compression and not tension. Okay, so we succeeded in obtaining the forces along the various bar. Okay, the force along bar BA, we obtained it to be 500 newtons, and it is what? Tension. The force along bar BC, compression, and 707.1 newtons. The force along bar CA, it is what? 500 newtons, and we notice to be what now? Compression. Now, in our next few videos, we're still going to be talking about the other parts. We could as well find the reaction at this point by analyzing joint A. But there's no need for analyzing joint A, since we are only going to be solving for the compressive or tensile force along these bars, okay, of which we have already obtained. So there's no need of finding the reaction. We're not asked to find that reaction. But if we have to find that reaction, we can also what now? Analyze joint A. Okay, so in our next videos, we're going to be taking some more complex examples, and we're also going to be seeing what we call the zero force members. That is, there are trusses in which the force acting on the members are equal to 0. That means they are just there. Not that they are useless, but the force acting on those members are equal to 0. That is, they are not supporting any load. So see you in the next video.